In this lesson, we're going to be taking a look at graphing radical equations. Now, this first one is actually one that you're familiar with, graphing the square root of x. And let's just remind ourselves how we got there and how we can make this graph. The square root of 0 is 0, so therefore we have the point 0, 0. The square root of 1 is 1, and therefore we have the point at 1, 1. The square root of 2, however, is a decimal. And I'm not worrying about plotting all the little decimals here. So I'm not going to worry about putting a point that's over 2. I instead want to go over to the next point where I actually can take the square root of the x value. So the next number I can take the square root of is 4. And the square root of 4 is 2. So that means I'm going to have a point that is over 4 and up 2. And I, again, want to look for the next number I could take the square root of after that. And the next number I could take the square root of is 9, and the square root of 9 is 3, hence why we go over 9 and up 3. And that's actually our entire graph here, because there's nothing on the left side, because you cannot take the square root of a negative number. Okay, now with that in mind, that's going to allow us to now go and make the graph of this, the cube root of x. So let's again start with 0. The cube root of 0 is 0. And the cube root of 1 is also 1. Same as the square root so far. But from here, not the same. What if I go over 2? What's the cube root of 2? It's another decimal. Okay, what about the cube root of 3? It's a decimal. Cube root of 4 then? No, the cube root of 4 is also a decimal. A square root of 4 is a whole number, but not a cube root of 4. So I got to keep thinking through all the different numbers and look for one that I can get the cube root of. And actually the next number that I can actually take the cube root of is 8. The cube root of 8 is 2. Therefore, I'm going to have a point that is over 8 and up 2, because I'm plugging 8 in for the x and I'm getting 2 out for my y. And yes, I could plot more points if my grid were big enough, but my grid isn't big enough over there. So I can't plot anything else over here to the right. The question though is, should I be plotting anything to the left? Well, can I take the cube root of a negative number like negative 1? Actually, yes. Because if I do negative 1 cubed, I do get negative 1. So the cube root of negative 1 is negative 1. Or to see another example, the cube root of negative 8 equals negative 2. Because negative 2 cubed, that is negative 2 times negative 2 times negative 2, is negative 8. And so if I go left 8, I end up going down 2. And so then this is my graph of the cube root of x. Now this should have a slightly familiar feel to it. You may recall that when we graphed x cubed, we ended up with a graph that looked like this. Very similar graph. In fact, it is the same graph, except it's been flipped over. Technically speaking, what's going on in the background is that if you drew in a line going through y equals x, that diagonal line right there, our x cubed graph is actually being reflected across that line in order to give us the cube root. Now, that has to do with inverses and some other things that we plan on digging into a little bit deeper later in the year to explain why it needs to be reflected across that line. But for now, I'm just going to plant the seed and let you see that, yes, it is the exact same graph, just flipped over that. The nice part is that because of that relationship, though, is it's going to make it easier to remember how these graphs connect to each other and what their shapes are. The trick is, of course, though, remembering which one is which. If you do have trouble with that, one way that some people find helpful is you'll notice that this part of our graph here kind of looks like a radical symbol, maybe if it's really blurry, but that might help you to remember that this is the one that goes with the radical. So now that we've graphed just plain old y equals the cube root of x, we can now graph it with all sorts of different transformations in it. So you should now be able to graph this particular equation. You notice the 2 that's multiplied by the radical, since it's multiplying, that's a vertical stretched by a factor of 2. Then the minus 5 that's on the inside of the radical is going to shift right 5 units. And the 3 that is on the outside is going to be shifting the graph down 3 units. Now we know it's going to be the same basic shape as what we just saw in the last one. So what I want to do first is identify where that first point goes. So instead of that first point being at 0, 0, it's going to be right 5 and down 3. So this is actually going to be the location of our very first point. Then from there, I just think about what would I normally do from that starting point. And remember in our last cube root graph, we saw that my first point after 0, 0 was at 1, 1. That means I went right 1, up 1. In this case, because of the vertical stretch by a factor of 2, and again, remember it's only a vertical stretch, instead of over 1, up 1, I'm going to go over 1, up 2. I still go over the same amount, but I go up twice as far. The next point I plotted after that was over 8. But I can't go over to the right 8 in this particular case, so that point won't fit. So I've done everything I can on the right side. So I already know that I'm going to end up with a graph that has this in it. But I can plot something on the left because this is a cube root, not a square root. So yes, points exist on the negatives as well. So normally I would go left 1, down 1 to get to my next point. Again, though, I have the vertical stretch by a factor of 2, so I'm going to go left 1, down 2. Okay. Then from there, normally I would go left 8. Yes, this one does fit. So we're going to go left 8, and left 8 is normally down 2. But of course, in this case, it's not going to be down 2. It has to go down twice as far. So instead, we're going to go down 4 when we go left 8. Now, if I want to see if I can go even further to the left, the next number that I could take the cube root of after 8 is 27, because the cube root of 27 is 3. I cannot fit 27 to the left on my grid here, so it's time to go ahead and draw the curve in. And there I would have my graph of the cube root function described in this equation. Let's go ahead and do one more graph here together. So I'd like you to graph this particular function. It'd be a great time to try doing it on your own first by pausing the video and then watch me walk through it. So the first thing I'm going to do is I'm just going to go ahead and again note what each of the transformations are in this particular equation. The negative is a reflection across the x-axis. The 3 that's being multiplied by the radical is a vertical stretch by a factor of 3. The plus 6 is going to shift it all left 6, and the plus 1 is going to shift everything up 1. All right, so I'm going to go ahead and put my first point where those shifts are taking me, which is left 6 and up 1. And then from there, it's a square root graph, which would normally put my next point right 1, up 1. But in this case, I'm reflecting it, so instead of right and up, it's going to go right and down. And instead of up 1, it's going to go down 3 because of that vertical stretch. So I'm going to go right 1, down 3 to get to my next point. Notice to get those, I'm always thinking back to what does the normal graph do, and then I'm just applying those transformations to it. All right, so my next point, because this is a square root, my next point would normally be right 4, up 2. So in this case then, it's still going to be right 4, but instead of up 2, it's going to be down because of the reflection, and it's going to be down 6 because of the vertical stretch by a factor of 3. And we keep doing the same pattern here. So normally then, I would go over 9, up 3. In this case then, that becomes over 9 and down 9. And then finally, if I go over to the right from there, the next number I can take the square root of is 16. The square root of 16 is 4, so I would normally go right 16 and up 4. In this case, it would be right 16 and down 12, which would be somewhere down here. And it's just off my grid, but I'm going ahead and kind of eyeballing where that would be because it's going to help me draw my curve in from there. And then the question is, should there be any curve on the left-hand side in this case? And the answer there is no, because this is square root. And remember, for any even root, you cannot take that root of a negative, including square roots. You can't take a square root of a negative number. And so this will be our entire graph. You will only have a left side if your root is odd, such as the cube root.